So welcome everyone. I hope you can now hear my voice. And I would like to kindly request all of you to unmute your microphone upon arrival and during the presentation to ensure that everyone can hear the presentation clearly. Okay, so let's then open today's session. Good afternoon, Europe, and good evening for everyone in Indonesia. Welcome to today's event, the 5G Open Run World Experience Sweden and Japan, which is organized collaboratively by TechBros GmbH, Telkom University, Telkom Intra Project, and Open Run Indonesia. So my name is Fani Marcela Maharani Idris, and I will be your moderator for today. So just give me a few seconds to turn off the chiming bell of the guest arriving. So, yeah. So, and yeah, just do tell me if you have problem hearing the audio of this webinar via chat, and so on. Great. Before we proceed to the main event, I would like to inform you that we will have a Q&A session at the end of today's session. So if you have any question during this event, feel free to write it down in the comment section and we will discuss it at the very end. So, okay, our agenda for today. First, we will have the first presentation from Mr. Indra Gunawan, Cloud Run Go-to-Market Program Manager at Ericsson Sweden. And then second presentation from Mr. Budiman Rosyid Muhyiddin, RF Engineer at Rakuten Mobile Japan. And then at the very end, we will have a Q&A session. And before we are closing today's session, don't forget to stay for a little while for our photo session. So before we open today's first presentation, I would like to kindly remind you to follow today's webinar rules and guidelines. First of all, please keep your microphone muted during the presentation and use the raise hand feature of the Zoom platform to ask questions and join the discussion. If you want, you can also use the chat function to ask questions and join the discussion, but we will prioritize the one that raising hand first. Don't forget to be respectful to your fellow attendees and enjoy today's session. So, without further ado, let's now dive into the first round. I have a great pleasure here of introducing our wonderful speaker for today. We're going to share with you their thought. First, we'll be hearing from Mr. Indra Gunawan, who is currently working as Cloud Run Market Program Manager at Ericsson Sweden. Mr. Indra Gunawan, if you're ready, the stage is yours.
Thank you, Fanny. Can you hear me okay?
Yes, perfectly fine.
Good. So thank you, everyone, for joining this meeting. Actually, I haven't prepared any slide, actually. It's more like a Q&A session, I think. But perhaps what I can share is a bit of my background. I mean, I've been working in the Cloud Run or vRun since 2016, I think. Yeah, so I started to work with the vRun, and that was back in.
Everyone who's not presenting, please, I kindly remind you to mute your microphone. Thank you very much. Yeah, we're really sorry, Mr. Asopa Indra. Please go on.
Yeah, sure. No worries, Fanny. I mean, as I said, I haven't prepared any slide, so I would say it's more like interactive session, Q&A session that I perhaps can answer some of your questions. But just to give you a little bit of background of myself, I've been working in Ericsson since 2006, I think. So this year it will be 15 years. I started in Ericsson Indonesia with Pak Yudra and other colleagues. I think I saw some people there from Ericsson also there. So then I moved to, I think it was Kuwait, South Korea, Switzerland, and Sweden since 2011. And I've been working in R&D for almost 10 years now, you could say. And as I said, that I've been working in the vRAN or Cloud RAN since 2016. So that is where I start the journey with the Cloud RAN / vRAN, with what we used to call it. And then I think it was in the beginning, my interest is that when we look into the future, when we are getting more blur differentiation between telco and IT, so I start to look into about this vRAN project, which I have vRAN technology. So I was started in 2016 to work with one of the customer in the US, and then it's continue. I think until together when I was working as 5G standardization manager, when we worked together with for the 5G NSA. So it was I'm holding those two roles, and then I was start to work on the Open RAN standardization back in 2018. And that's mainly in 3GPP. We have a working group called SF5. We're really focusing on management and orchestration, and I was focusing really on the XNF. XNF is like PNF, CNF, and VNF. So I was working on that standardization body to really look through how will be this lifecycle management all of this XNF in Open RAN standard. And then it was continue until for almost 2 years. So 4 years switch between project and standardization. And since last year, I mainly focus on Cloud RAN go-to-market. So this is a program within Ericsson where we are trying to work on our Cloud RAN solution. So I'm, you could say, preparing the sales readiness, service readiness, and also working with R&D to prepare our solution readiness. So when we deploy to the customer, we make sure that it can go smoothly and really fulfilling what we call a cloud native application. So I think that's basically about myself. I mean, I don't have any presentation slide, so I would expect it's more like Q&A. But I saw from Fanny that we will have another session in the last session, right? So looking forward to have more discussion with you. I think that's it, Fanny, from my side.
Okay, thank you very much, Pak Indra. Then we'll be opening the Q&A session in more detail later after the second presentation. Okay, then thank you very much for the sharing, Pak Indra. Now we will welcome our second speaker for today. Yeah, welcome to Mr. Budiman Rosyid Muhyiddin, an RF engineer at Rakuten Mobile, Japan. Now we'll be turning to the other side of the globe, from Sweden to Japan, and maybe Mr. Budiman can share us his perspective about working as an 5G or Open RAN engineer in Japan. How's the working life? How's the living situation, and so on.
Uh,
Okay, to
am I
Mr.
audible, Ken?
Budiman, if you're ready.
Okay. Am I
Yeah,
audible?
perfectly. Fine.
Okay, thank you. Good afternoon, all in Europe. Good evening in Asia. Maybe I will give you some presentation, because around like 10 or 15 minutes. Let me. Can I have co-host permission?
Yes, now you're a co-host and can share your presentation.
Okay. Let me see. Okay, 1 minute. Oh, what's happened? Yes, can see my presentation.
Yes.
Okay, so sorry, I made like a short presentation, maybe too simple for us, but it's enough to describe what are we doing here in Rakuten, what are the virtual restaurant, what is 4G or 5G. So currently I'm working in Rakuten Mobile as RF optimization engineer. As you know that Rakuten Mobile has built the first world end-to-end virtualized network, which is it's full virtualized, and this is the cloud native mobile network. And the network is a real implementation of Open RAN. So today, maybe I will share you a general preview about VRAN implementation for 5G network in Rakuten. I can start with a short video that to show you the journey from the beginning of the Rakuten Mobile. Sorry.
The network began in suburban Tokyo in late 2018. February saw the successful completion of its first end-to-end test, connecting real-world users across mobile handsets on the new network for the first time. Rakuten has taken a unique and transformative approach to building a telecommunications network, leveraging world-class partners across a system that has disaggregated hardware and software, putting the entire virtualized network on the cloud, including radio access, and delivering a new level of stability, scalability, and agility.
And this is our CTO, our CEO.
With over 70 e-commerce, fintech, and content services, a powerful brand, and 100 million registered members in Japan alone, Rakuten brings the power of an established ecosystem and the dynamic skills of a global tech company to telecommunications in a way no one has seen before. A fully virtualized network allows a shift away from the model of the past, in which the hardware and software are tightly coupled. In line with the principles of cloud computing, Rakuten Mobile Network will create service delivery platforms with greater agility and customization. The new network will launch around 3 major metropolitan centers to be followed by a nationwide rollout. Rakuten's innovative 4G network architecture is also being developed to be ready for 5G. 5G rollout will be simplified to steps such as adding the 5G network equipment to existing antenna.
Well, Rakuten's biggest advantage is work culture and people. Rakuten is not a telecommunication company. We're an IT company with highly skilled IT engineers and professionals, and that is what's making a difference in how we're building and constructing this network. Well, in an industry first, we have deployed and worked with leading partners to deploy the world first virtualized radio access. This has never happened in telecommunication. This is a big evolution to the industry, big advantage to what Rakuten is doing in Japan.
By electing to build an open, virtualized, and disaggregated radio access infrastructure in collaboration with best-in-class partners, Rakuten has been able to greatly reduce the equipment required, making radio access sites around Japan simpler and more compact. Rakuten is on track to launch a 4G network that is also 5G ready. The entire core technology, including the radio access network, is fully ready for 5G. Bringing world-first technological innovation to the telecommunications industry in a way only an agile internet-driven company can, Rakuten is setting the bar high for delivering better, faster, and flexible services to mobile customers.
Okay. Yeah, you can see the brief preview of the Rakuten now. Maybe the next step after you can see after this, maybe you guys can see all the brief review of the Rakuten, what is the background of Rakuten. It was not a telecommunication company, it was IT company, e-commerce company, which is start to move the tons from the telecommunication to IT. So we can start with the 5G network in Rakuten from the allocation band. So currently Rakuten Mobile has two frequency license for 5G. It is TDD, and first frequency is we are using sub-6 frequency with band number N77. It is a range between 3.8 to 3.9 gigahertz. Yeah, so it wants only 100 megahertz bandwidth. For the second frequency, it's called FR2. Rakuten has MMOF frequency, and the band number is 257. Its range is 27 gigahertz to 27.4. So Rakuten has 400 bandwidth, 400 megahertz bandwidth. And recently, we just got new update that Rakuten Mobile has just received approval to expand 5G via 1.7 gigahertz, which is mean that we will have more 5G coverage in the future. Okay, so the next slide is you guys can review here about the simple architecture of 5G overrun. If you saw this slide, I believe most of you has familiar with this overrun architecture. As described on the previous video, that Rakuten has built RAN network with simplified, virtualized, and eliminate some RAN blocks hardware which we found on previous network legacy. So, and now Rakuten already prepared this new platform as default architecture for 4G, which they will start to build this network since 3 years ago when they start to implement their first telecommunication network. So when 5G start, this G-Node B sites can just easily integrated with the network without any hardware upgrade required. So if you can see here in the G-Node B run, it is split into virtualized block for VCU, divided into two parts: VCU control plane and user plane. And another block is G-Node B DU, a connection between CU to DU. We have at F1 interface. So F1C for control plane interface, F1U for the user plane interface. And then from DU to RU is connected by ORAN standard option 7-2X, which is the ORAN standard interface. And currently for RAN vendor, we're using Altostar, and for RU or radio panel unit, we're using NEC. So the remaining component of G-Node B are fully virtualized and can be run on any Intel x86 architecture-based commercial off-the-shelf or COTS server and Kubernetes container orchestration platform. Okay, for the next slide, we can see more deeper for the GNodeB functionality split here. For the upper figure, you can see the illustration of the GNodeB functionality for frequency 1, which is sub-6 frequency. We have a split level between GNodeB, DU, and a third party using ORAN defined option 7-2 from in the front hall. So, and because in sub-6 we have a different hardware between RU and DU, so it's separated between RU and DU, and below block is GNodeB functionality for frequency 2. If you can see in this mmWave frequency, GNodeB DU and RU are combined in one radio panel. We have NAC vendor using for this radio panel, and from DU to CU is connected by mid-haul F1 interface. So this is some more brief review about the CU architecture. So for the control plane, DU control unit, sorry, for CU, we have GNodeB for it can support for the major function that it is in CU level. We have LT functionality like for PDCP control plane, SDAP, RRC, RRM, and also the termination of the N2 interface, F1 control plane interface, and also in CU level we have sound features, API security, and of course also for OIM. This is for control plane unit. So for user plane, it has similar functionality, also similar as control plane. So this in user plane, the difference is we can support up the, it has a terminated of a PDU session, and the PDU session may be distributed up to 5-6 cells supported by GNodeB CU user plane. So now we're moving forward to GNodeB DU architecture. For GNodeB DU sub-6 or frequency 1 consists of DU software, and we have Intel FPGA based hardware accelerator card. So we have accelerator card here to support this DU functionality. So the use of this accelerator card is for offloading FEC, or it's mean the forward error correction processing, and optionally for front haul CU plane compression. For DU sub-6 support for the following function. For this in previously in CU we have L3 functionality. In DU we have L2 functionality like radio link control, MAC layer, and also 7-2X ORAN interface to RU, and also this in the DU also we have termination of A1 control plane, F1 control plane, and user plane, and also in DU we have security on mid-haul, and also we have OM functionality for this in this DU. And for mmWave frequency, DU has a different functionality because here in mmWave we don't have L1 baseband interface, because L1 baseband interface has separated in radio panel in NAC. So in DU we have only L2 baseband, and functionality similar as DU for sub 6. Okay, so we can go to the next review about 5G transport network. If you can see here this transport network of each part of the front haul, mid haul, and back haul has lower latency required for 5G. For 5G transport, we have split into some parts which they have low on threshold for latency. In front haul, for example, the DU and RU connection, we have latency low within 50 to 200 microsecond, and the distance allow to 10 kilometers. And in the mid haul, we have around 1 until 2 millisecond latency that has tolerance 20 to 40 kilometers distance between DU to CU. And the back haul, we should have less than 10 millisecond latency within 40 until 200 kilometer distance between CU to 5G GC. Okay, we going to the next review about the OM configuration. If you can see here in the OM configuration of even this is also applied for 5G in our network in Rakuten, all are handled by cloud network, which is we have Kubernetes, Kafka, Grafana, and CMAS, and everything are doing by automized, everything like virtualized, and we cannot see any hardware on it. So we can see that Gnode BCU control plane and user plane and Gnode BDU are managed entities with are directly managed by OBF. OBF is observability framework, or in our legacy network, it's called NMS. It's using Kubernetes container. So if you guys already familiar with the cloud network, it's a good benefit for you, because in the future, this will be very useful, and it's the future of the telecommunication. What is Kubernetes? As we know that Kubernetes is open source container orchestration platform that it is enable operation of Elastic Web Server framework for cloud application. So it's mean that we don't need to it will not have in the future, we will not have any capacity issue, any problem with the capacity. Just Elastic expand the network based on our network demand. Is that the benefit of the cloud network we have here in using Kubernetes? So this OM configuration consists to functionality. Is the 4 major functionality we have. Firstly, as configuration management. As you know that for the configuration management of the Open Run, it's based on RU, DU for sub-6, and it's all controlled by the cloud. And also we have fault management, and all the DU, CU as RU are managed directly into fault management event notification with the OBF. We have using web scale friendly protocols such as Kafka message bus or another thing. So this is everything are new for us. Even I'm not have deeply familiar with this, because this fully cloud network that we need to start to learn again as you know that our job as telecommunication engineer, mostly we have dealing with RF and everything. So, but now we need to have familiar also with this cloud network. And also we have like a performance management that in this Kubernetes, in this cloud also manage the performance management counter generated by CU in DU, and is yeah, this directly ingested into OBF and MF using web scale friendly protocols such as Kafka. So the performance counter of the ORAN base ORUR specific by the DU as CSV format. It defined already in ORAN workgroup 4 and plan specification. And also we have log management also here, managed by OM configuration in Kubernetes. So everything are managed, virtualized, and everything are managed here in the cloud network. We don't need, no hardware involved again. So yeah. Now we can continue that was in the previous slide that was discussing about mmWave and sub-6. Maybe for this simple explanation, you can see what is hardware configuration of the mmWave and sub-6. So you can see here, we have, as I told you earlier, that in mmWave, we have 400 megahertz frequency band that recently we can have into four layer, divided each layer we have 100 megahertz, and we have in one radio panel we have also DU, one DU per sector. So each sector has for each sector has 100 we have 4 sector, and each sector has 100 megahertz, and it's handled in one DU, and it's then it's connected to CU. So in this DU and RU is integrated in one panel. And then it will be connected by CU using cloud network. So in sub-6, DU, RU, and CU are separately individually. So in sub-6, because we have only 100 megahertz frequency band, so one RU handle 100 megahertz, and one DU we have 3 sector and 3 RU, and from CU we can have up to 85 video for one CU, and CU and DU is located in GC group center, and CU is in RDC. So this is the simplified network of hardware of mmWave and sub-6. The next is the sample of development configuration. This is for sub-6. So you can see here from the CU is connected by to Kubernetes-based platform, and it's connected to DU also by the cloud network connected to Kubernetes platform, and going by DAC fiber cloud is connected to RU. So yeah, it's this is one of the deployment configuration of the virtualized run we have here in Rakuten. And another implementation here for mmWave. So this from CU, we directly going to dark fiber cloud and connected to DU and RU in one panel on the cell side. So yeah, this is one of the, this is, of course, this is a simplified network. So you can see this brief review about the Open RAN or 5G here in Rakuten. I think that's all from me. So after work, I like cycling. And you see in Japan, it's good, really the best place for cycling. So you need to balance your life between work and personal life and your family. So yes, that's all from me for tonight's presentation. Thank you.
Thank you very much, Mr. Budiman, Rashid Muhyiddin, for the very insightful and detailed presentation. Now, I would like to open the Q&A session for all of us. But before, I would like to remind our audience again about the rules and guidelines for today's webinar and Q&A session. Do please keep your microphone muted if you're not asking any question or not joining the discussion. And first, use the raise hand feature of the Zoom platform before unmuting yourself. And optionally, you can also use the chat function to ask questions, but we'll prioritize the one that raising hand first to ensure that today's Q&A session will be dynamic and interactive. And don't forget to be respectful and enjoy today's discussion. And now I'll be opening the discussion for the first question. Anyone raising hand first? So first person to raise hand here is Mr. Soman Tahir, I guess. If you please unmute. Hello.
Good evening. How are you? Hi, can you hear me? Am I audible?
Yes, now I can hear you. Yes.
Okay. First of all, thanks to you and thanks for every speaker. The presentation is really helping and really informative for the basics levels. First thing this one. Secondly, I have a question from Muhyiddin that he defined about the configuration and all that thing. Can he just elaborate in the basically that what I learned, and that in vRAN and in Open RAN, the basic difference in the vRAN, we still have some specification or restriction regarding the vendor or regarding the software utilization or the configuration. But in Open RAN, we can go for any software with any vendor. So can he explain that they are using the same kind of vendor for the software and hardware, or are they using the different and using the defined protocols or interfaces by the 3GPP?
Mr. Soman Tahir, if you can also address which speaker your question for, or for both of them.
It's for Muhyiddin, the second guy who explained in the detail with the presentation.
Okay, thank you.
And secondly, that's one more thing that is not the technical actually. I think so everyone is concerning about the presentation. Will it be possible that the slides or the recorded presentation is available later on the page or by the email?
Maybe I can answer about the presentation. For the presentation, unfortunately, it will not be possible to send the slides to the participant because it's regarding confidential issue. But for the recording, I need to ask other party first.
Yeah, sure. Thank you.
So
and
then,
regarding that technical question, you can Mr. Muhyiddin can answer me about that. Yeah, my answer is a simple question is that one, are they using the same hardware and the software for the configuration of vRAN and Open RAN, or they are just following the interface defined by 3GPP and they are picking the different hardware and different software from the different vendors?
Yeah, thank you so much. It's a good question. So Rakuten picking up a different vendor and for the developing network, and it's based on 2GPP and Open RAN standardization. For example, the RAN vendor they're using Altiostar, and a 5G radio panel they're using NEC, and some small cell they're using different vendor like Airspan, uh, and another different vendor, and they are using also different vendor from the different for different. So basically it's like more to Open RAN. We are using a different vendor for each part of the network, and based on standardization in 2GPP and Open RAN.
Thank you. Just one last
Mm.
thing. The frequency band which you defined and the frequency range, it is usually, I think so, the same which we are using in the 5G network. So basically, the Open RAN currently Rakuten is defining is on the 5G frequency bands, and they will further proceed or evaluate the 5G network while using the Open RAN and vRAN. Is it?
Yeah, correct.
Okay, thank you. That's all from my side, and any other person they can ask the question. Thank you.
Okay, thank you, Suleiman.
Okay, thank you. And one other person is currently raising hand, Mr. Muhammad Lutfi Asyafi. If you want to ask any question or also join the discussion from previous discussion question, please.
Okay, thank you. Thank you for Mr. Budiman for this presentation. I am very interesting. My name is Muhammad Lutfi. I am from Indonesia. I have one question. What is the 5G architecture and Rakuten use purely cloud native infrastructure like Kubernetes and many more? And is it still research or has it been implemented on production? This is my question. Thank you.
Yes. Can I answer directly, Fanny, with this question?
Oh, yes, please.
Okay, thank you for the question, Muhammad Lutfi. So it already implemented in the commercial network since last year for 4G, and starting this year for 5G. So it's already implemented. Of course, for some development, we still ongoing in our lab, but this this Open RAN network already implemented since last year. Yeah, and currently we have around 3 million subscribers for the Rakuten in Japan.
Yeah, I hope your question is already answered, Mr. Muhammad Lutfi Asyafi.
Yes, thank you for this answer. I am very interesting for this topic because in Indonesian, wait. Thank you. No more question.
Yeah, thank you very much for the question. And then moving on to the next person, Mr. Bambang Chandra is currently in the queue.
Yeah, hello, Fanny. Thank you. Yeah, I have one question, to Mr. Budiman. I just want to know what the obstacle during the implementation 5G in Japan, especially in Rakuten. That's for the first one. And for the second, what kind of tool usually for doing the troubleshooting for like the optimization and RF analysis? I think there's only that, probably our question. Thank you, Fanny.
Okay. Thank you, Bambang, for your question. Fanny, this Bambang is my teacher for this.
Really?
Yes, he's my master. So yeah, Mr. Bambang. So the the blockage during our implementation. Of course, this is because this is a totally new network and new just implementation, and we don't have too much time for like R&D research something. So many bugs would happen in the current network we have. So yeah, currently it's still ongoing. It's going much better every day. So but we still keep improving for this issue. So of course, so many issues happen in this new network, but we still try to improve by, I mean, our cooperation with our vendor and our subcontractor. That's for the question. So for the second question, for this basic RF analysis and data analysis, we have like a in-house tool developed by our NMS tool. So I mean, we have like a call Foresight. In Foresight, we have like a live test analysis. I think yes. We using like Foresight here in our network. So this is we can use for analysis for drive test and tracking log, drive test log or something. So this is a basic tool that we have for drive analysis and also for like a daily performance analysis. And also we using Redcom for end-to-end trace analysis. So also to analyze layer 3, it's standard, like we can use like Wireshark or GXDM, something like that. The tool is general tool, like we have used to as RF tool that we have. So, but we have here additional tool that developed by in-house in Rakuten. We have Foresight here. I mean, it's developed by Inuai actually. This for Rakuten. So in Foresight, we can have like in one place to check to have a drive test, check drive test log analysis, to check the performance analysis, something like that. Okay. Is it?
Okay. Thank you, bro. Yeah. Thank you,
You're
bro.
welcome.
Yeah.
You're welcome.
Like, be carefully, yeah, in Japan.
Don't be naughty, okay, Mr. Bambang.
Yeah. Thank you. Thank you, bro.
You're welcome.
Yeah. Thank you for the question, Mr. Bambang. So it's quite a nice reunion here right now.
Yes. So Mr. Indra is my old teacher, Fanny. Yeah, we working together when you
really?
were in South Korea. Yes, he went to Sweden.
It looks like I'm really old, Budiman. No, I'm not that old.
yeah, but you look like young.
Everyone is connected. Okay, let's moving on. We are currently have 6 people in the queue. The first one is, I hope I pronounce your name right, Mr. Yusuf.
Yes, correctly. This is me, Yusuf. Thanks, Mr. Mohoiden, for this nice and useful presentation. I just have 2 questions. First of all, regarding the architecture used for the radio units, I would like to know, like, the radio units used here are like type A or type B, and how this would differ in terms of the front haul, like dimensioning or bandwidths required. This is my first question. My second question related to how vRAN impacted some features, like intersite features, like carrier aggregation between, for example, different sites, and was like the vRAN deployment had a positive or negative impact on this. For example, like inter-CU carrier aggregation was possible or not, or inter-DU carrier aggregation, and like features like combo, for example. Yeah, that's it.
Yeah. Can you repeat the first question? What kind of, type of are you said?
Yes, you mentioned like radio units were used by like NEC. there are like in the low level split like 7.2x, there are two types, either type A or type B. What was like the type of radio units used?
Okay, for the type of radio unit use, let me check again for this detail specification, because I did not too aware with this radio unit. But for the second question you have about the features, currently, yes, we are still developing of the. Currently, we have only like a basic features in the available light commercial network. So usually we discuss with our vendor, and we give some proposal for them to have more, maybe initial required additional feature that usually we can found in the major vendor that we have now, like a Nokia or Ericsson or even Huawei, like a Com or something like more the advanced features. So yes, that I can answer that we have some features, but mostly it's basic features, and additional features as we required, we are discussing with our vendor to be added, and near future developed build. So yes, so this is still on progressing for this additional.
Okay, many thanks, Mr. Moiden, for your answer. Thank you.
You're welcome, Yusuf.
Yeah, thank you for the question, Mr. Yusuf. And I would like to remind you for further question to also mention to whom the question is addressed, to Mr. Indra Gunawan maybe, or to Mr. Budiman, or for both of them maybe. It's also possible. Next in the line is Mr. Sabto Agung Wibowo, please.
Okay, thank you, Fanny. I want to ask to Mr. Budiman or Mr. Indra about the explain. I want to question, the first question about 5G. Can use transmission microwave or must be fiber optic transport? And then Mr. Budiman explanation about the one antenna sectoral have 4 cell and 1 cell have a 100 megabytes, and 1 cell have a 400 megabyte, and totally to 1.2 gigahertz. Actually, I have a newspaper in Solo business, Telkomsel trial in Solo. Actually, downlink 100 megabyte and uplink 30 megabyte. Ask to Mr. Bundan, why actually 5G cannot 1 gigahertz? Actually 4G in Indonesia maximum until 40 atau 50 megabytes. Maybe Mr. Bundan have experience why we cannot until 2.2 gigahertz megabyte. Thank you, Budiman.
Okay, thank you, Mr. Sabto, for this question. So I can answer this question first, and later on maybe Mr. Indra can give additional with more deeper technical explanation. Why in Indonesia maybe we cannot get the maximum bandwidth as described in the, or based on calculation, as because maybe Mr. Sabto think that in another country, in the developed country like Japan or Korea and another country, we can gain this level. Maybe it's but the most factor is in the transport. In the transport legacy that we have in Indonesia, as you know, that fiber is very limited bandwidth compared to Japan, that in Japan all the sites are connected by fiber, not not microwave. So this from this factor will be different. It make one different because, of course, on fiber it will be have more better bandwidth during transmission compared to microwave, something like that.
Mr. Budiman, can
yes.
use microwave 5G? Or no, or must be transport in fiber optic?
For update microwave specification, I'm not sure because I working like around 10 years ago with Ericsson, and at that time the latest specification of microwave cannot fulfill the high speed requirement as now 5G. So it is maybe possible, but we need to have the good, the microwave with high capacity bandwidth.
Oh, maybe in Indonesia have overall in 5G, yeah, because in Indonesia so many fiber optic in all around Indonesia. Yeah, Pak Budiman.
Yes.
Thank you, Pak Budiman, Fanny, for your time.
Maybe Indra can give additional explanation regarding this, because you are in mostly in research and development, right? So you know much better about this specification.
Yeah, well, that's not the agenda that I'm aware of. No, so I'm joking. My specialization is actually on the cloud O&M cloud infrastructure. So the one that Budiman said, that in this CNCF, this Cloud Native Foundation, and how do we do this automation across multiple OpenStack like Kafka, Logstash. So I'm more on the upper part, you could say, on more on the management and orchestration. So I know few, and in R&D is the way where we work is we are, you could say, if you look on the how we work in market area or customer unit, it's more like T-shape, right? Everyone is have a quite broader knowledge on multiple areas. You have knowledge in transport network, you have knowledge in what they call radio, you have knowledge in the baseband, and while in R&D is the opposite. We are working on the T, so it's really deep dive on the specific area. That's why I mentioned that I'm mostly working in the automation part. So if you're talking about how our network will evolve in few years, in 3 years from now, and then what kind of the tools is going to impact network rollouts, customer support, network design and optimization, that is what I'm working at the moment. So I don't know. If you ask me why why the 5G speed in Indonesia is not reach 1 gig, the answer is not, I don't know. First is that's not the easy answer to give, because we need to understand how big is the frequency band, what kind of feature are you using, carrier aggregation, or how are you I would say it's more complex to really measuring what is the peak bit rate compared to just like identifying only specific, let's say, oh, that is due to fiber optic. I would not exclude other factor also, let's say the dimensioning part, and then the let's say additional feature that you need to activate. So that's is really good questions, but it's tricky to answer without knowing all the details.
Thank you, Pak Indra and Mr. Budiman, for your expression.
Thank you.
Yeah, thank you also for the question, Pak Sabto. Unfortunately, it's already almost 13 o'clock in Germany, and I think 6 p.m. in Indonesia. So unfortunately, we have to end today's Q&A session due to time restriction. For those who still have questions, we will have further webinars and events and also trainings program to deepen our knowledge in 5G and also openness. So stay tuned to TechPros LinkedIn, because in our LinkedIn we will frequently post about event like this. So yeah, before we close today's session, I would like to ask our participants to turn on their camera, because we will now take a commemoration photo for today's event, if you might. So let's wait for a few more seconds. Okay, for the first page, then, okay, 1, 2, 3, smile. Again, 1, 2, 3. And then for second page, 1, 2, 3. Third page, 1, 2, 3. Page. We have fortunately many participants today. 1, 2, 3. And last page. 1, 2, 3. Okay, thank you everyone for participating for today's session. I would like to give my thanks again for Mr. Indra Gunawan and Mr. Budiman Rashid Muhyiddin for joining us today as our speakers and for sharing knowledge and also sharing their experience in working in Japan and also in Sweden. Yeah, and I hope that from today's session we've learned a lot. And don't forget to stay tuned to TechPros LinkedIn for further webinars like this, if you like it, and also maybe web trainings programs where you can also earn certificates from it. Okay, thank you for stay tuned in today's session. I would like to close this webinar then. I hope you guys have a pleasant weekend, stay healthy, and see you in the next webinar. Bye.
Thank you. Bye-bye, everyone.
Bye-bye.
Bye. Thank you.
Thank you.
Thank you all.
Bye. Thank you.
Bye.
Bye. Thank you.
Bye.
Bye.